Hello, everyone. Good morning.
Good morning, sir.
Good afternoon. Happy Sunday.
I wish you the same.
So we'll just wait for another 5 minutes for people to join in. How's the election in Nigeria? Anyone?
Yeah, it's going on well. We are still on it. We are still on the election.
Who's winning?
Well, at the moment, we are not sure yet, but the figure is looking inconsistent yet.
Okay.
Yeah, so hopefully between tonight or tomorrow morning, we should know the winner.
We can see some new people joining us. We can see Purnansh Goel, Vani Goel, Shilpi was here yesterday. We can see Yog. Who is Yog? Can you just Purnansh, can you just introduce yourself? Purnansh. Yog. Yog, can you just introduce yourself? They have logged in, but are they on mute or they? They are on mute. They are on mute. Yeah. Who's Mame?
I am.
Okay, and you are from?
I'm here.
You are from?
Ghana.
You are from Ghana. Welcome. Yeah, welcome.
Yes. Thank you.
Purnansh, are you there? Purnansh Goel, Vani Goel.
Hello, my name is Tunde.
Okay, welcome.
From Nigeria.
Okay, good. Welcome. Who is Yog? How many people have joined? So,
That is Tunde from Nigeria.
can you go on mute, please? Can you please go on mute? So, good afternoon, good morning, and namaste from India. Welcome you back for session 2. I hope so. You did spend some time on other videos which are already there on the module, on the platform. Because most of the videos are already there, which you can see before coming for the session. However, we'll be covering during the session as well, but it becomes easier if you watch the video in advance. So we welcome you once again, and today we will straight away we'll go to the modules. As I said, when we teach with a lot of approach with the industry. We are totally connected with the industry. So you can consider this as a part of workshop, the technical training, when we are connecting to the industry. We will not get into too much of theoretical part, but even that's a theory part, I'll be explaining this on R. So we'll be coding on R, and I'll be explaining the outcome on board. And that is important. I hope you all have downloaded R and R Studio and Python. I assume you have downloaded R and R Studio, Python, trial version of Minitab. If not, please do so that we can start the session. Let's go to the board. Yesterday
I'm
also
okay.
yeah.
I'm
Screen share.
please.
Screen share.
Hello.
Yeah, I can hear you.
Yeah, please. I've been able to install the RNR Studio, but I'm finding difficulty with the Python. Can you?
No problem.
Can you?
No problem. After this, we are not covering Python today. So we will help you after the session. Please schedule a call with us or come on a Zoom link or Google Meet and we will help you downloading everything. So don't worry at all. We are not covering Python today.
Okay. Thank you.
So yesterday we started with the basics of statistics. We discussed the difference between statistics and mathematics, the difference between a sample and a population. We also said that any improvement that we drive in our business, in our processes, we are actually trying to improve the population, the entire process, with the support of a sample data. Then the objective of any project is to make a model. When we say model, we'll discuss as we say what is a model. When we talk in terms of data science or analysis, what is a model? In our simple language, when we talk about model, let's say we want to construct a house. So we build a model. Bedroom will be here, washrooms will be here, living area will be here. We build a model according to our requirement. Similarly, and that model is accepted by you, or that model is accepted by your customers as per their need. Similarly, we build a model in business using some statistical tools so that this model helps your business grow. This model is acceptable by the management. This model can predict the revenue the customer experience. Now, when we talk about statistics or data science, we talk about stage 1, stage 2, data science, machine learning, artificial intelligence. Remember one thing, this entire statistics are just based on primarily 2 measures. And these 2 measures are very strong and they are very powerful. So these 2 measures, what we always think of, mean and standard deviation. If you understand these 2 terms, how the data can be understood just looking at the data, that's it. Now when we talk about training, how we train, we start from, let's say you are getting data every day in your mailbox, attachments. You are getting some sort of data every day at your desk. Any report from MIS, from operation, from quality. You have a data. What to do next? What should we do next? What should we look at inside the data? How much data should we look into? Is it for me? How do I treat the data? How do I study the data? How do I see some patterns in the data? How do I measure the metrics? So that is how it all starts in any business. You and me are receiving some data every day. But because you're not conscious, you're not aware of some of the tools, so we are not being able to extract the values from the data. Every data point, trust me, every data point has revenue. Every data point has customer experience hidden in this. What we are learning is the skill set or the skill to extract the revenue, to increase the customer experience from these data values. So understanding the data is more important than running a code on Python or R. Even if you run the code, if you master the code on R or Python or Azure ML, SPX, any platform, but if you cannot bring any insight, if you cannot understand what each and every data value is talking about, all your coding on Python, Power BI, everything, whatever you're doing is of no use, because you'll not be able to give an insight to the management or to yourself. That is why when we talk about this entire thing that we are learning in next 8 weeks, or even if you say next 1 year, we are focusing on mean and standard deviation. Then comes median. Then comes median. How they are related, how does it work, how does it show you a true picture of your data, even before you get into any analysis. So please, on the platform there is one data. On your platform, under basic statistics, there one data called dataset car R part 1. Please open this data, download it, and save it in a CSV file. It is already there in the CSV file. Please open this data sheet and also open R, your R Studio. Open R and open the data sheet. We will learn how to upload a data in R. Yesterday, we showed you the basic features of R. What is R for? What are the features on R? How do we use them? And as we practice, we will learn the basic operation, the basic codes. And we will learn practically with a data set. And as we code, I'm using the wrong word, let me tell you, coding. We are not coding. There are predefined codes already there. It is just like Excel. If you want to find average in Excel, you must know that you have to type average. Rest, it gives you the formula. So it is just based on practice. Similarly, R or Python is just based on practice. If you practice hard, within 15 days, you'll become a master. But R is vast. It's very vast. And it has a lot of features. And so is Python. But we will go slow. We will practice from the videos later on. So don't get into any sort of panic or don't get nervous and this is difficult. It's not difficult. It's not a rocket science. It's very easy. And it all depends how we learn together. So let's open new script. Go to file, new file. I say R script. When you get R script, you'll see a blank source, and let's delete the consoles. We have cleared everything.
Sorry.
Yeah. Yes.
Please, can you come again with the the data you said we should?
Okay. No problem. Yeah. If you come to your platform under basic statistics.
And some of us, we are finding difficult to even locate the website.
No, the website we have already given the course courses.abstl. You already have a link. Click the link. Can you just forward the link on batch 2? Just click the link and you will reach the platform. So under this platform, you will find basic statistics, and in basic statistics, and basic statistics, you have a data set, car, R, part 1. Did you get it?
I see our operation with sample data. And
No,
then
R data set, car, R part 1. You can see on the screen. Can you see my screen? We have sent you the link also in chat. Can you see the screen?
okay.
Have you download, please?
Data set car our part 1. Okay.
Yeah.
Yeah, please. When I open the website, it says 404. The page you are looking for doesn't exist.
No, hold on. Delete the other things. No. Just type in. Just type in.
Okay. I when I click on the back home, it opened for me. Thank you very much.
Okay, so download the data and we will come to R. Open the script. Go to file, open a blank script, R script. Once you're there, come to environment. From here, import data set, import from text base, use from text base. And you can upload the data from your own system because your data is saved on your system, not my system. But I'm uploading from my system. So it is here on my system. I click this, I say open. This is a very simple thing. We all do it in all the platforms. So this is nothing tough. Once you come to this screen, don't do anything. Just say import. The moment you import the data, you will see your data over here. So what you need to do, come here or just press this back button. Press the back button. Once you press the back button, you will come back to your screen. Now what you need to do, on your console, you will see this file. I hope you all can see my board, our screen. Is it visible? Can you see the board?
Yeah, it is visible.
Okay, so now you copy this and paste it over here on the top in the source. There are different ways of uploading data, but I'm just telling you one way. After doing this,
Hello, sir.
yeah.
Anu, please, I think you are
Give
going
us some 2 minutes. Can you please give us some 2 minutes to download the template from your website? We are finding difficult to even locate it.
But it is, yesterday also I showed you, I took you to the platform, I showed you the modules. Have you downloaded?
Anu, please, after downloading and open R, where do you go?
Save that file on your system.
You are saved.
And I hope this is saved in CSV format. That
It's
is already
already-
a CSV file. That's already a
already-
CSV file.
It's already in CSV.
Okay, save it somewhere on your system.
Okay.
Now, once you have saved it, and people who are not being able to do it, you can watch the video also later and you can download. Come here, import data set from text base. So once you click this, you can choose the file from your system, wherever you have kept it. For instance, I have kept it over here. My file is here. I open it. Very simple thing, what we do every day. You will come here, import this file. Once you import the file, you can see your file over here on the top. Just go back on this back button and you can. Now what you need to do, you copy this from your console, copy this, paste it over here. Paste it over here. So I'm deleting the first one because I don't need the first one. Once you've pasted, just scroll to the right. In the end, after the inverted comma, put a comma over here and just say header. Just write header, you'll get a pop-up. You'll get a drop down, say equal to, and say true. Select the true in capital letter. Okay, enter. This is your run button, which we had discussed yesterday. This is your run button. We run it. Now, what has happened? We have uploaded the data. Now, please pay attention. This is, we are creating an object where we are saving the data. You can name it anything you want. You can save this data in with any name of your choice. So I'm putting as cars GA so that we all are working on the same file. At this moment, right now, please save this as cars underscore GA. Cars underscore GA, and this is your file is saved. This, and we just run. If you don't get any error, it means your file is saved. Your file is in the object called cars underscore GA. Fine. So now what to do? Fine, I uploaded the file. We can see different operations happening on R. So first thing I want to see my data. In order to see my data, very simple English word, view. The moment I say view, it will give you the option. Select that and put the name of the data. The data is called GA here.
Some of us are totally lost. We can't get the files.
Sorry. So
I'm not
once
able
you
to
use-
get the files.
Which have you got the data?
Yeah, I got the data.
Yeah, so let's see, we cannot go very, very slow. That is the reason we had asked you to watch some videos. Okay. So it may not be possible to go very, very slow. So, and that's why even after and in the first class itself, maybe you'll not be able to get it. Walk slow, but you can also watch the video and you can practice. So don't worry about it. And now we have just started. We've just started. We'll be working on our. So you will start getting it in practice. So just don't worry about it.
But
So when
at
you-
least our colleagues that were able to download, can you put it on the chat so that we can also download from the chat box? That would be fine.
No, we have already shown you the right. We have already given you the link, right? You can see. Have you opened the platform? Have you opened the platform?
No, I can't open the platform.
No. Have you opened the platform?
Which platform? Is it the student login platform?
Yes.
Yes.
So that is where we have the data. You have to get used to the platform. Under the basic statistics, you will see this data over here. See this data set card part 1. Download that.
What I saw here was data science stage 1 and data science program details.
No. You come here, scroll down. There is one option to enroll in the free course. Click that free course.
Wow.
Please, on the dashboard, where do I go to? Live session, library, bookmark, or community? Where do I go?
Open the learner platform. See, if you go to the course, can you send it on Excel?
I am active courses.
Yes, right. See. When you come to the courses, you will see, click this one. Data science stage 1, first step to predictive analytics. Please click this one. The moment you click this one, you will come to the platform.
Your dashboard looks different from mine. I have active courses. I have active courses and archive courses. Do I go to active courses or archive courses?
Active courses.
Okay, active courses is say go to store.
Can you
don't have any courses.
Can you share your screen, please?
Okay, so this Gloria, if you give me the access to share my screen.
Gloria.
Yes, you've disabled sharing my screen. Gloria, J-Jom, how many? DZIE.
He's giving you the. You have the permission of please share your screen.
Okay.
Gloria.
Yes, sir.
Try and go to your dashboard where you saw your picture. There's a dashboard there. Then your interface will look like his interface.
Okay, hold on. Okay, come again. So I should share with my dashboard.
No, you share your listing with them as they are guiding you.
Okay, moment.
I'm also having the same challenge here. The thing is not.
So that is why we always say, practice, open, go to the platform, see. Please share your dashboard.
I think to register course before you can see it on your active courses.
Is it, Alex, you do what?
You need to register for the course first, then it will appear on your active courses.
So where do you go after you have seen the basic statistics?
When you get to your page, you click on courses.
Okay, courses.
Yes, click on courses, then you see the courses. So you click
big
on that,
data.
and that's
You mean big data, data science free, data science program details free. Which one? Data science stage 1. First.
Please share your screen, Gloria. Gloria, please share your screen.
Gloria, you share your screen with him so that we can all.
All right.
Follow the step.
Okay. First screen. Okay. Okay. Am I sharing?
The
Yeah.
third one.
The third
The
one.
third one. Okay.
Yeah.
Yes.
Okay.
Now go down,
Scroll down.
scroll down.
Okay.
Scroll down. Yeah, now go to course. Yeah, get course for free. Click there. Yeah, now come on to the left. Come to basic statistics. Yeah, scroll down. Down. Come to basic statistics. Basic.
This.
The basic one
Okay.
here. Go down.
Should I scroll
Go
down
down.
again?
Yeah, basic statistics. This one. Yeah.
That's where you are.
Okay,
Okay.
go down. Yeah, you see the data set. Yeah, the data set
Up.
up.
1, 2.
Down.
No.
Yeah, you can see this data set over here.
Data set car R, part 1.
No, yeah, down.
Yes, the next down.
This
next
one.
The next one, yeah.
Can you download here? Yeah.
Okay.
Okay, so now let's go back.
Okay. Thank you.
So Anu, please
Ready.
help with the quotation.
Sorry. Okay, so now that we have uploaded the data, and please watch the videos. That's the reason we say always watch the videos so that you can practice. Because it will be very difficult to go so slow. We'll not be able to complete our modules for today. So
Okay. So now we should follow you then later watch the videos and practice, right?
yeah, just follow. If you're fast, if you can follow, please follow. Else, the video is always there for you to practice.
Okay, all right. That's fine.
Yeah. So now.
Okay. Thank you.
Yeah. So now I want to see my data. I say view, and I put the name of the data where I've saved it. I say. So it shows you the data over here. Right. I go back. Now and we will go slow with the coding. Now, what is the point? You have the data. You have seen your data. What next to do? What should I do now? What should I see in data? So first, I want to see the type of my data. I want to see the structure of my data. Because if your structure of the data you understand, only then R will be able to accept it. If you put in wrong data, if you put in wrong type of data, R will reject. It will throw an error. So let us see the structure. And R understands it very well. I just see str, structure. Okay. And I put the name of the data. Cars GA. Let's see what it gives you. And trust me, guys, coding is not tough. What it gives you at the bottom, that is important to understand. It's very important to understand the outcome for your business. So let's say I say str. I click, I run this, and this is what I get. And now on R, you can move these boxes from here. You can select, you can also move it from here. I want to see the bigger size. So let me shift this side. I want a bigger screen, and I want to see this. So this is a structure. It says the data frame. What is a data frame? Data frame is your data set. All the columns and rows, all the values that forms a data frame. We have 442 rows and 14 variables. Let's see on the Excel. If you see on the Excel, sorry, I think I opened the wrong data. So So if you see on Excel, there are 442 rows. And how many columns are there? How many columns did you see? There are 14 columns. And there are 442 rows in my data set. And this is what R is telling you over here. 14 columns, variables, and 442 rows. Now, what do you see about these things? When you say CHR is a character, R takes any ABCD as a character, the way we learned in Python yesterday, which shows string. In Python, it will tell you a string. Here, it will tell you as character. Age is taking an integer. If there's no decimal with your number, if the R says that there's no decimal with your number, it will take it as integer. So you see, there's numbers without decimal, it takes as integer. When you have decimal, it'll take as number, NUM. So now we need to understand the type of data, which is very, very important. So let me come to the board and let's talk about types of data in any data science, any analysis, or wherever we are handling data. It's very important. What are the types of data we deal with in our daily life? Continuous data, or we also say numeric. And I will explain to you in a very easy way. Then, and this also we can call quantitative data. Then we have categorical data. R understands this as factor. R will understand this as a factor, the categorical data. When the continuous data, R understands this as NUM, numeric. So let's discuss for next 10 minutes what are the types of data and why this is very important for you and me to understand for any analysis. Who can tell me? And let's make it interactive. Please ask questions. And whenever I ask questions, try participating. Nobody's wrong, nobody's right. We all are learning together. So let's participate and encourage ourselves to learn more. What is the continuous data? Who can tell me? Has anyone heard what is the continuous data? What is the continuous data, or let's say numeric? Yes, Oscar?
If I hear a question, well, what I understand is it's a data that are in numbers. They are in numbers.
So if I say 1, 2, 10, 15, are these continuous data?
Are they what?
Are they continuous data? Is this
They are continuous data. They are continuous. No, these ones are not continuous data. They are not continuous data.
Okay, so you're good. You're answering it correctly. So what is the meaning of continuous data? The
data
word.
which can be measured.
Sorry?
The measurable angle of the data. So the data which can be measured can be called as continuous data.
Okay. So every data can be measured. And that's what we are saying. The word, what is the word?
Continuous, infinite.
Continuous. What is the meaning in English? What is the meaning of continuous?
Repeating.
Yeah, what is the meaning? What is the meaning of continuous?
I think it's something that follows a sequence.
On it.
Something which continues, right? Continues, correct?
It
Without
keeps
stopping.
occurring.
Something which happens without stopping, correct?
Yeah.
That is the meaning of continuous. So if I say between 1 and 2, how many numbers are there?
Infinite.
Infinite, right? You cannot count. You cannot count. It can be 1.1, can be 1.001, can be 1.2111. It is continuing. And then comes 2. So whenever we have the continuity in data, and in data when you say continuity might come with decimal, that is a continuous data. Let's say weight, I am 65 kg, 500 grams, and then milligram, and so on and so forth. If I say time, 2 hours, 40 minutes, 30 seconds, and then nanoseconds goes on. Something which is further divided, something, a unit or a measure which can be measured continuously. That is the continuous data. But if I say books, I can count the books. 1 book, 2 books, 3 books, 4 books. We never say 2.5 books. We never say 5.5 books. So, but if I say, it's very important to understand these basics, the concepts. And that's why I focus on the concept first. Let's say, two books, 100 books. We are counting. But these are also numbers. These are also numbers. But these are not continuous numbers. We don't count book in decimals. So remember, guys, one thing. When you start practicing on all these things, what we are talking will come with experience. The number which we talk about, it also depends on the type of business you are into. So when we say 2, this is an integer. This is an integer. When we say continuous, when we say 2.5, this continuous is continuous. This is an integer. But integer and the numbers of continuous number both come under numeric. Both come under numeric data. So under numeric data, you have integer and you also have continuous. And we will learn as we go that sometimes why my integer works like a continuous. When should we use the integer as a continuous? We will learn as we proceed with the program. But these are the basic things you must understand. So if I say volume, is a continuous data. Time, continuous data. Age is a continuous data.
Can I
So-
ask a question, sir?
Yeah, please.
So one of the variables we normally work with in the health industry is the age
Yeah.
of respondent. So
Yeah.
that is actually an integer, not a continuous variable, right?
Okay.
Thank you very much.
Oscar, I think, it's a telepathy. What you asked, I was going to discuss this. I was discussing and you asked me this question. Excellent. So now let's say I write that my age is 47. This is an integer. Mathematically, this is an integer. But you always say age, 47 years, 5 months, 10 days. You always keep the age this way. So this is actually a continuous data. If you write only 47, R will take it as an integer because there's no decimal attached to this. So R will read it as decimal. So whenever you're doing the analysis, you have to follow what R takes or what type of data you have to input. Have I answered your question?
Hello, sir.
Yeah, Oscar, is this
Yeah,
clear?
please. The integer we are talking about, is it also what discrete data means?
We are coming there. We are coming there. We are coming there. We are coming to discrete. So now we will talk about categorical, or R understand this as a factor. R will understand this as a factor. What is a categorical data? If I write excellent, good, poor, these are some of the categories we are building. But I have a question. We all know something which can be measured will be improved, or something, if you want to improve, should be measured. So if I just write excellent, good, or poor, does it make any sense? These are just English words. Will it make any sense? We know excellent is better than good, good is better than poor. You understand this, I understand this. How will R understand this? So what we have to do, we have to define these terms. So let's say excellent, if it is 5, is excellent. Is 4, is good. Is poor, is 2. We are defining it with a number, because any statistics of R or Python, they only understand number. They will not be able to measure the characters or the strings. So this is what we call categorical data. And when we learn sometime, we will talk about the dummy, how we create. That is in stage 2. When we get into the detail. This is a categorical data which is known as factor in R. And let's see on R. Here, R is not showing anything. It has taken 1 and 0 as integer. So what is the next thing that we need to do? I will come back. Let me complete this. So the one is the continuous data, or under numeric integer and continuous. The second is the categorical data, or what we also call discrete data. Discrete. The word discrete, what is the meaning of discrete in English? Let's understand statistics with simple English words. If you try to break the problem, your project will be much better. Don't always work with a big problem. Break the problems into chunks and then analyze each problem separately to get a better result. So that is the reason when I'm saying I'm focusing on English terms. What is the meaning of discrete in English? What is it? What is the meaning of discrete? Anyone?
I think discrete means specific, like something
Sorry?
countable.
Sorry?
Something countable.
Okay, something countable, right?
Yes.
Okay. What does discrete mean? Something unique. There is no discrete. You can discriminate between this and this, which you can count. 1 book, 2 books, 3 books, 5 apples, 5 bananas. So this is what we call discrete, which is also, you can say, the categorical or the factor we are talking about. Something which is unique. So now, another type of data is ordinal data. Try breaking this. It talks about order. It's an order. So if I say excellent, very good, good, and poor. So this is ordinal. We all know excellent means top. Then very good, good, and poor. This is your ordinal data. So these are the basic types of data that you must understand and you must apply when you're analyzing your task or when you're analyzing your data. So now I come back on R and explain again, and we will see the factors. So why it is giving me integer? Because it is just reading as a number, 0 and 1 as a number. But actually engineers, MBA, they are all categories. By default, R will, whenever you have 0, 1, R will treat this as a factor when it's 0, 1. So what we need to do now, the next thing, fine, I've seen this, but a male, female cannot be integer. Okay, 0, 1. So I want to change it. I want to change this into factor. I want to change age into number. I want to change rest into factors. Let's see how we can change. Very simple, very simple. What is our data? Cars underscore GA. This is the data we have. Put a dollar sign. And when you put a dollar sign, it gives you the list of all the variables under this data. I say age equal to, very simple, I say as dot factor. The moment you say as dot factor, or let's say I'm taking as numeric, age will be numeric, as dot numeric. I say as dot numeric and I put in the car data again. Car G, I put the dollar sign again. Why it is happening? Let me explain. And I run this. Okay. Now I want to see the structure again. Has it changed? So now you see, age has changed to number. What is it actually doing? Our data is stored over here. I've taken the data, and within the data, I'm selecting one variable called age. How we select the variable from the data? By putting this $sign. When you have selected the data age, we are just running one function, which is as.numeric, because we are changing to numeric. And we put in the data again. It changes. It is this simple. Now I want to change something to factor. Let's change to factor. Similarly, same, everything is remains same, nothing changes. I want to change, let's pick up anything. I want to change female to factor. So now here instead of saying numeric, I will say factor. And same thing, I'll take female. And just run. And let's see the structure again. So you see now, female has changed to factors with 2 levels. 2 levels means it has only 1 or 0. But thing is, you know what? Today we have only 14 variables. What if I have 500 variables in my data? How will I change all these together? So we want, because without changing, you will not be able to analyze. Because R will understand that this is a number. It starts giving you average. But if I'm saying either a male or a female, there cannot be any average. There cannot be any median. There can be a mode. So, but R will start giving you as an average because it is taking as integer. It will give you the average of 1 and 0. Let's change everything together. All the variables which we need to change, we want to change together. We don't have so much of time of typing in 1, 1, 1, 1, 1. Let's see, very easy. Just a very simple code. What we do now, you see, under this, we have age as a number, we have work experience as a number. So first, let's change all the numbers. Let's change numbers. Is equal to as.numeric. Class age, work experience. I'm changing this just one by one. Okay, but then we will change a lot of things together. So I just copy this because I just have 3 variables which we need to change to numeric. I paste it over here. What I do, I just change this part. Now I've taken work, I will take the salary. I will change this here also salary. Done. Okay, I take another one, I paste it. I take a distance because we have one more variable which is a continuous data. Take a distance. You're also taking as distance. Done. We have done for the numeric data. Let's see the structure again. Wow, see the magic. All these have changed to number. Now I want to change all these integers to, I want to change to factor. Whenever we have 1 and 0, we will change it to factor altogether. So what we need to do now, we need to create another object to store all the factors. Okay, so what we will do, we will see from here. Car data, and we will pick the name from here. Because I cannot see, I cannot scroll over here every time. So we create another object. I say let's cars underscore factor. Cars underscore factor is equal to we are picking from the data. Okay. Let me show you over here itself, which. So what we are doing, we are creating another object to store all the factor variables. So what we are doing, and whenever you're please practice, you always type. Don't copy and paste from somewhere. When you type, you will get to know it faster. I say cars factor is equal to, that is column. See, I'm taking as column and I'm picking up all the variables from this. The first was a female. Okay, let me pick female. Inverted commas. Female, comma. So, comma, and you take this MBA, no MBA, yes, whatever you can see. We have everything over here. So we are picking up all these variables and we are trying to convert them into factor. So I'm showing you on the part which we have already done. Now, let's say I remove this bracket by mistake. By mistake, I leave this. You can see someone coming over here telling you that there's something wrong. There's something wrong in the coding. And it's an unexpected token and it's showing you a bracket. So we close the bracket. And the moment your code is right, you will not see this pop-up. Yes, Oscar?
I want to find out this stage. What actually are we doing? What is the name of this stage?
We are converting the types of data. We are converting the integer to factor. R has taken it incorrectly. R understands 0 and 1 as integer. But for us, it is a factor. So we are changing into factor.
Thank you, sir.
So we have picked up all the variables all together and we store it in this cars factor and we run. Now, the next step, what are we doing? We are trying to change all of them together. So cars, GA is our original data. And remember we are saying $sign. Here instead of $sign, I'm putting this object over here. I'm just putting this object with this square bracket. And then one function which you need to remember, this is apply, apply. This is a function which will actually convert them into factors. Here we were saying individually, we were saying as dot numeric, as dot factor. Here what we are saying, we are using a function called apply, cars, GA factor, comma, just a factor, and everything changes together. Now let's see the str again. How to see the str again? Str, the structure, cars, GA. So now what it has done, it has changed age to number, female, male, engineer, everything to factor with 2 levels, salary and everything to number, license everything to factors. Now my data is ready. Now this name, what is this name is still showing character. Now what does this name indicate for how important it is in your analysis? This is also a factor. Means A, B, C, let's say you have 5 team leaders in your group. So these are my team leaders. This is my data for my 5 team leaders. So this is also a factor. So we will change this also to a factor. So a very simple thing. Let's change it over here. A car GA, $sign. What are we trying to change? Quick, who will tell me? What are we trying to change? Which factor?
Name.
Excellent. Name is equal to as dot factor car GA dollar name is done. Now guys, whenever you are making notes, and you must make notes, you see this hash sign. In Python yesterday, we were trying to learn the heading, the markdown for the paragraphs in vehicle. It's similarly over here in R, when you put the hash sign, it will not take it as a code. It will take it as a text, your heading, subheading, whatever notes you want to make over here. And so see, I've made notes. So when you practice, you will see that I've explained everything side by side, what this code is used for. All the steps have been explained to you. So when you put the hash, it will take it as a paragraph or header. It will not take it as a code. If you put the hash before the code, it might be different. Always put the hash after the code or in a separate line. Fine. Now, so you know what? We have changed everything to factor. So how does it help me? What should I do with the data? Have I become a champion? No. First, we're just trying to see my data, which has come from my operation team. And I'm seeing the variables. But if I don't understand the types of data, I cannot analyze. In order to study engineering, you have to first identify your subjects, maths, physics, maybe chemistry, maybe economics. So in order to study engineering, you need to have some subjects. Similarly, when you do some analysis, you have to put in certain types of data. Not all the data is accepted. And this certain type of data, you have to know this is your skill set. This is the skill you have. So now that the data is here, I'm fine. I have converted my data. I'm ready with my data. Then what next? I understand type of data. Continuous, discrete, categorical. I've understood. So what to do next? Let's see what my data is telling me. Sorry, no, fast in what sense? Am I speaking very fast? No, am I speaking very fast? Hello? I'm just trying to explain the concept. R will come with practice. We have a lot of time to practice, so don't worry. We will be using the same.
Sorry, I have a question.
Yeah.
I have a question.
Yeah, please.
This converting to factor. I want to get something clear. Is it that it's a must for us to always convert data into factor? Maybe if it's an integer, we take it to factor. Is it we'll be working with factor? Or what actually is the basis for our conversion?
See, this is what I told you. R understands this is a categorical data. We are saying when we are converting to factor, we are saying it's a categorical data. Okay. It is not a continuous data. So when we move ahead with the analysis, somewhere you have to take Y or X, which we learn as categorical, somewhere you have to take continuous. That is the reason why the right type of data has to be fed into the system, to the platform for the right analysis. Otherwise, it will give you an error. So just hold on. And as we practice, we will learn this. So factor is just a category. I said you have 10 team leaders. A, B, C, D, E, F, G, H, I, J. So under these team leaders, you have agents. So this is a categorical. You're creating a category of team leader A, team leader B, team leader C. You're creating a category. And I understand this as a factor. So now, fine, we have changed the data to different types. What next do we need to see in our data? We want to see the summary, the mean, median, mode. What is my data telling me about today's performance? How's the business performing today? So let's see the next step. And now, also remember, you must attach your data. What is the meaning of attach? When I say attach, and I say class GA, I'm attaching the data. What does this mean? It means our student now knows all the variables it has all the variables in its memory. I don't need to type in with variables. The moment I say age, it will give you age over here. Okay, it will give you age. Because we have attached the variables to the memory of R. So you don't have to type in again and again. Now let us see the summary of data. I'm really interested in seeing the summary, what it really talks about. So we will come, guys, we will cover everything, don't worry. I want to go some step by step with the explanation, which is very, very important. So I want to see the summary of the entire data set. So if I say summary is summary, English word, summary, class age, class GA. I want to see the summary. Let's see what it shows you. It gives you let's say for age, minimum, first quartile, median, mean, third quartile, and maximum. It gives you 6 items. So now we will understand everything, let's say based on age. We are not bothered about female, male because they are categorical data. It should not give you any average or mean or something. We are not concerned about this. We are concerned about age, the continuous data, salary, a continuous data, work experience, a continuous data, and distance, a continuous data. Why? Because mean, median, standard deviation, when you deal with them with continuous data only. Now, we have to understand this, and this is the most important part that I'll be covering. If you can understand this part, you are half an analyst already. Half of this program is well understood by you if you understand this part, and I will make it very, very easy when I'm explaining. I will connect it to your business. So now what we are talking about, the entire data science, your project, my project, business, we all are working on graph. We all are working on mean and standard deviation. How is mean? How is this a very powerful tool? Why am I saying understanding these 5 or 6 items? It will make you very powerful when you analyze the data. It will really make you very powerful. And what are those elements? Mean, median, quartile 1, which we will understand, quartile 2, quartile 3, IQR, minimum and maximum. half your analysis or what your data is talking about today, if you can understand this, you are done. So we will take a small break, 10 minutes break, and we will come back and we will study this. And because I want to spend some time on this, I want to bring some clarity on this. And that's the reason I'm saying take a break, refresh your mind, and we'll meet again after 10 minutes. Thank you. Stop the recording. Okay, guys, we are back. I hope we all are back. I can see only 13 participants.
Yeah, we are.
What is mean or average? What is the meaning of mean? Let's say we have a team and the performance is 10, 90, 55, 20, 20. This is the performance. So what is the meaning of mean? The average, correct?
So mean means that the total number of the observation divided by the number of observations.
Okay, good. When do we use mean? When do we see mean in our performance? The mean of this, whenever you get your data, what do you want to check? You want to check the average first, or the mean. So remember, mean takes all the values. It takes all the values. Median takes only the mid value. Mean will take this. Median, if we put it in the descending order or ascending order, it will only take this part. It will only take the middle value. But thing is, why are we learning this? How is it going to help us? Remember one thing. Mean, you should look at mean according to categories. If you want to calculate the mean salary of entire company, that would be wrong, because the CEO may be getting this amount, a team leader may be getting this amount. So comparing the salary of a CEO with a team leader is not the right approach. So your mean will be inflated. You will also see some extreme numbers. This is an extreme number, this is an extreme number. So mean takes into consideration all the extreme values, which is not always the right way to measure something. Later, when we talk about outliers, we'll discuss how it affects the average. So now let's say, now the mid value will take only this. It will not take the extreme values. So I have a question now. Let's say you have team A and team B. Team A is at 10, 55, 98, 20, 75. Team B has a score of 55, 60, 65, 68, 50. This is team A, this is team B. And let's say, I'm not counting it right now. Let's say this team has a score average of 55%. This team has an average score of 85%. If you have two teams, one is performing at 85%, the second is performing at 55%. Who will you reward? Who will get the prize from you? Who will get the clapping from you? Which team will get the clapping?
The one with 85%.
Sorry? Sorry? 85 or 55?
85%.
85%. 85.
Yes. If you look at the data, 85% will get the reward, the winner. But don't forget that we have some extreme values. Look at the variation. It means the second thing which we need to understand is standard deviation. Whenever you measure something, whenever you measure a team leader or performance, don't just look at mean, also look at the standard deviation. Standard deviation is nothing but the deviation from the average, which we will learn, don't worry. It is deviation from the average. I have another question. Which team is more stable, this team or this team? Which team has better stability?
Team B.
Team B. So we will come back to yesterday's session. Sorry guys, I have a bad cough. What is the objective of any project improvement? We discussed yesterday. What is the objective of driving a project or improving a project? What is the ultimate objective? Who remembers?
To improve the model.
No, improve the model is fine, but what is the final objective? What does the CEO wants to see? From the improvement that we are doing, what are you trying? Yeah, result. But what should your model be able to do?
Improve the performance. The performances.
Your model should be able to predict. Ultimate goal, which we discussed yesterday, is the prediction. Whether your improvement, whether your performance based on improvement, can you predict for next 3 months or not? Can you predict your score for next 6 months or not? That should be a model. So now if you look at this team, can you predict your number? Can you predict your revenue or the quality score or the customer experience based on team A?
No.
You can predict, but whose prediction will be better? Team B.
Yeah.
Because team B is more stable. Right? So whenever you are trying to measure something, always look at the mean, always look at the standard deviation. That is very, very important. Because ultimately you are trying to build a model which should be able to predict for next 3 or 6 months with certain level of accuracy. So maybe you are rewarding this team, but you are forgetting that this team is more stable, this team is more reliable in your business. So the idea is to bring this team's performance in terms of stability, stabilize the process, stabilize the performance. So now what is standard deviation? What is standard deviation? Let's say I have a team and the score is 20, 30, 10, 50, 20. I take the average 5, 6, 11, 13 divide by 5. So that is 26. This is the average. This is the mean of this team performance. How do we calculate standard deviation? You don't need to learn all the formulas. You're not doing anything. You're just putting it. I'm just giving you the basics. This is my average minus 26, minus 26, minus 26, minus 26, minus 26. Minus 6, 4, minus 16, this is 24, this is minus 6. If you add all these things, if you add them, it will be 0. This is equal to 0. Because you have minus plus minus plus, so it becomes 0. So what do we do next? We square this. They're very basic things, and we must know how to interpret outcome from any statistical platform. Now we square this. When we square this, (36), 16, 16 to 16. What is the square of 16? 256. What is 24 into 24? Fast. What is 24 square? 396. Is it? Can you confirm? Is it 396?
576.
Good. I wanted to hear from you. Good. And this is 36. We have squared this. Negative part is gone. We add it. Please add this for me. 72 plus 16, 88. 88 and so this is 920.
920.
I take this average, divide this by 5.
184.
184. 184.
Yes, 184.
This is your, this is the variance which I will talk about right now. Now I will square root this 184. Can you square root 184? 33,000. 184, just give a square root, not square. Square root.
13.56.
Okay, excellent. I square root this and it is 13.6 something. Okay. This is your standard deviation. You don't need to learn the formulas. So what is the meaning of standard deviation? That how much are you deviating from your average? You have different teams, different agents under each team. How much is each agent deviating from the team average? That is the standard deviation. Lower the standard deviation, better the performance. So if I take the average, the standard deviation of this and this standard deviation is lower. So this is very, very important to understand why we look at mean, why we look at standard deviation, and how does mean affect your business, your performance. So next thing is, we have learned the standard deviation. Now there is something known as variance. There is something known as variance. Can anyone tell me what is the variance? What is the relation between standard deviation and variance? Very simple thing. We have learned in our schools. What is the relationship between standard deviation and variance? How do we calculate variance from standard deviation?
The square of standard deviation.
Yes. So if we square this, you will get this. So standard deviation is equal to square root of variance, or let's say variance is equal to standard deviation to the power 2. This is simple, but there will always be a question. The difference between standard deviation and variance. As per the formula, variance is equal to variance is the square of standard deviation. Is a square of standard deviation. Fine, we have learned that. But when do we use standard deviation? When do we use variance? That is important to understand. We said variance is the square of standard deviation. But remember one thing. Let's say I have 5 teams. Team A, Team B, Team C, Team D, Team E. I'm just giving some numbers. These are your 5 teams. You have 5 averages, you have 5 standard deviation. The basic difference between standard deviation and variance the standard deviation will be calculated only for individual columns. The standard deviation of this, they'll be separate. Standard deviation cannot be added. So let's say the standard deviation of this is 15. Standard deviation of this is 10, 20, 5, or let's say 10. This is a standard deviation of 5 different teams. Standard deviation is measured in the same unit. So if you have weight, if you have height, the standard deviation of weight will be measured in weight. Standard deviation of height will be measured in height. You cannot add this plus this plus this plus this. You cannot add standard deviation of 5 different teams, but you can add the variance of 5 different teams. So variance of this will be 2 to 5, 100, 400, 25, and 100. You can add the variance to see the dispersion of the entire team, but you cannot add the standard deviation together. So whenever you have different teams and you want to see the dispersion, the deviation, you will always take variance. But when you are dealing with just one team, you will talk about standard deviation. If you talk about, let's say you have height, weight, volume, and the standard deviation of, let's say, is 30. So this will be 30, let's say, centimeter. You're talking about height. So standard deviation will be 30 centimeter, 40 kg. And let's say this is 20 cc. These are different units. Why are we talking on this? How is it related to your business? How is it related to your daily work? Why are we talking about different height, different measures, standard deviation, variance? There's a reason. Because when we're driving a project, when you're trying to improve something, when you're trying to improve a quality score or a customer experience, you're making some changes in manpower, you're making some changes in the technology, you're making some changes in the finance, you're making some changes in resources. All these are measured in different units. But when you make some changes in all these variables, only then your customer score or experience will improve. That is why when you take variance for different columns, it can be added, and you can say that the entire process, entire business has a variance of this. But you cannot add standard deviation. So whenever you're improving a business, how does a business improve? How does the improvement work? It's that simple. This is my why. Why or response, or we also call it dependent variable. It's either why or response, or this is called dependent variable. This side is your x1, x2, x3, x4. Let's say I'm putting x1 as a height, x2 as a weight, x3 as a volume, x4, x5. So whenever you make some changes over here, this will change. If you make some changes with this and this will change. When you are making changes with 3 factors together, this will change. When you're adding So when you're making some changes, maybe you're changing everything. If you have to improve the customer experience score, you have to improve the knowledge of your people. You have to improve the professionalism of your people. You have to improve the technology part. So when all these driving factors work together, the why changes, the improvement comes. Now the question is, how much to take that we will learn when we do regression. That how much should I change this? How much should I change this? How much should I change this? How much should I change it to bring the right why? Anyway, so this is right now, this is out of topic. We will learn after 1 week. So this is what we are talking about, the standard deviation and variance, which is a very, very important part to see when you're looking at the data. Else, we will not be able to analyze anything. Fine, this is okay. But what happens? What should I see? You say, Anu, you told us the differences, you told us the theory, but how is it applied? How should I apply this mean median in my business? That should be a question. So let's see how it will be applied. I come back to R. And when we run the summary, very simple. You see, writing a code, it takes 2 seconds. You're just writing summary and it's giving you a code. It's not a rocket science, but understanding this is critical. Understanding this is important, and that's what we will learn. So let's say I'm just taking one example. I'm taking the summary of age.
Yes, my hand is up, sir.
Yeah, please.
Yeah, if I get you right, you said the variance can be added. Now, when we add the variance, do we go ahead to divide it by the number of observation again, or you leave it as it is?
No. Very simple. We said, this is my variance. I'm adding the variance of this plus this plus this plus to see overall variance of the process. To see the variance, the deviation in holistic. Is this clear? Is this clear?
Please come again, sir.
I'm saying when we add the variance, we are adding the variance to see the dispersion, the deviation as a whole for the entire process.
Oh, okay.
Okay? Yeah.
Yes, please, sir. Thank you.
So now we are studying this. We are studying the summary of age. We have, now you can see the minimum is 18, first quartile is 25, median, mean, third quartile and max. Let's do it on Excel and let's see how it happens and what does it mean. So I'm just taking this age and we say equal to average age. This is my mean. Median, Q1, Q3, what is the median? I say median. Q1, I will explain this Q1. when you have to find the quartile one, you say quartile, select this, give a comma. The moment you put a comma, you get drop downs. So I want to see the first quartile. Similarly, I want to see the third quartile. What is I through R? I through R is nothing Q3 minus Q1. I will subtract this Q3 minus Q1. This is my I through R. I will explain what this means. What is my minimum value in age? I take the minimum value from here, 18. What is my maximum value in age? 40. Fine, I got this. So what should I do now? I mean, I can see Q1, Q2, but what is the significance of this in my data, in my business? That should be a question. So now if we look at this, and I will show you with a visual, I'll show you with a graph. This is a box plot, which we will learn at a later stage. What do we take away from this? Now listen to me very carefully. If you see this mean and median, ideally they should be very close to each other. Over here it is. Your mean and median should be close to each other. It means the middle value and the average of all the values, they should be close to each other. It means that the distribution of data is close to normal. And when we discuss normality, then we'll discuss this. It means in the terms of distribution of data, there's not much problem. Because the mean and median, they are very close to each other. What is the minimum and maximum? Minimum is 18 and maximum is 40. It means that your data distribution of the values, the deviation is very, very high. There's a problem of stability. One person, I mean, someone is at the age of 18, someone also has an age of 40. This indicates that there are some extreme values. This indicates that there are some possible outliers. It means that your data, the stability of data is not that high. It means there are some extreme values which you need to treat, or maybe you need to remove them to make the data stable. This I through R, or let's say the range. Range is nothing maximum minus minimum. Range is maximum minus minimum. Your IQR is 5, whereas your range is 22. There's a big difference. What does this mean? This means that the variation around the median, and median means, let me explain to you. When you say median, when you say median, it means 50% of your data values. Here I have 5 data values. It means 50% of your data values have a score of 85 and above. 85 and above. Please pay attention. Median is the middle value. Over here, 85 is a median. It means it says that 50% of the data values, which is 5, is above median and is above the score of 85. 50% of my total data values, or let's say you have 20 people in your team, it says that 50% of your total team members is above 85 and 50% are below 85. 50% are above 85, 50% of the people are below 85. That is at the median level, if we look at the median. But if you look at the mean, you have to look at the range. Oh, sorry, I was using Excel because I'm looking at the board. So if you look at this part, it says that 50% this IQR is 5, range is 22. As we said, we measure everything either using mean or we measure using median. So if we are measuring using mean, you can see the range between minimum, maximum, and minimum. It is 22. But if you look, if you are measuring it with the median, your IQR is 5. This is the deviation of the dispersion of data. What does this tell you? This tells you that my data of age is okay around the median, but it is not good if we take the entire data as an average. There are possible extreme values or the outliers. Between 18 and 40, there are possible outliers. Hence, it's very important to know the difference between the IQR value and the range value. Ideally, both should be same. If you see the mean and median, both are same. But the IQR and range, they are not same. There's a wide difference. So this clearly tells me, this clearly indicates that your data is not properly distributed because there are some small and large values at the end. And these large values are affecting your analysis, is affecting your result. So you'll ask me, so what should I do? I can't change the data. Yes, you cannot go to the management and tell, boss, the data is not wrong. There are a lot of extreme values. Mean is not good. Median is not good. Please change the data. That doesn't happen. You will lose your job. You don't have to change the data. You have to refine the data. You have to treat the data before building a model. And that is a real skill set of an analyst or a data scientist. Re-engineering the data, redefining the data without changing the data or without losing information from the data. You have to redefine the data. You have to re-engineer the data. And there are certain ways we re-engineer the data. In this case, I can see some possible outliers. There's some extreme values. Maybe some extreme values, maybe it's a typo. Instead of writing 5, someone wrote 50. Instead of writing 10, someone wrote 100. Maybe because of this, the extreme cases are coming. In that case, you can remove the entire row or the data values. But treatment of data, or changing in data, removal of data without the permission of the business, without the permission of the champion of the project, is a crime in any industry. You cannot just remove any data on your own. Why am I saying this part? Because when you go into the project in real life in the industry, you will come across all these challenges where you cannot remove the data. You will say that as an analyst, you know what, I saw this and you see, there are a lot of outliers, so I want to remove the data. You cannot do that. You have to take permission from your business owner whether they can remove the data or not. Why? Why this is very important? There are reasons. Remember, you are doing a project, maybe you're a champion, you're a project lead, or you're driving a Six Sigma project. And knowledge of yours is very, very important. So when we say, and this will come with experience, it doesn't come with one project. Who can try? Who can try to explain the difference between statistical significance and the business significance? Anyone try the difference between the two? Nitin, Shivam, Michael, Oscar, anyone try the difference between the two? It's very important when you're doing a project.
I know statistical significance has to do with an agreed value, which from epidemiological background, it is being quantified as 0.05. That is what I know about statistical significance.
Excellent.
But with the business significance, I have no idea.
Okay, excellent. The first part is right. Anyone else who wants to try? Guys, let's talk. Let's participate. You're not wrong. You're not right. I'm not wrong. I'm not right. Even I don't know everything. I'm still learning with you. But then we should not feel shy speaking something in the public. Let's try something. Let's participate.
For me, I don't know any of it.
That's a good answer. That's a good try. You tried well.
Business significance is related to, I think, the real world scenarios, and statistical significance is more over a theory or.
Okay, you're also right. You're also right to some extent. Let me explain this. Statistical significance. Let's say you're a data scientist, you're a data analyst. You're doing some analysis. Let's say I'm a salesperson and my performance in 2023 or 2022, January, February, March, April, May, June, July, August, whatever, till December. January, I had 10 million. February, I had 8 million, 6, 9, 11, 13, 30, and let's say, 11 million. This was my performance in the year 2022. Now, when I'm doing a statistical analysis, let's say you don't even know me, you don't even know my business well. And suddenly you will, if you do this, you will realize that this is coming out as an extreme value. You're between minimum, what is the minimum? 6. Maximum is 30. The range is 24. And you'd say that this is an extreme value or this is an extreme value. But the question is, from your analysis, this is an extreme value. Statistically, this is an extreme value. Now, if you have to re-engineer the data, you have to redefine the data, if you have to transform the data, you may think statistically, you may want to remove this because it's affecting the average. It is a possible outlier. So statistically, you may want to remove this. But if you remove this, I will ask the management that, sir, this was the performance. I was lucky in the month of July that I got a sale of 30 million. I got a sale of 30 million. Is it my fault? So if you remove this, what will happen? My entire average will go for a toss. I will not get my incentives. I will not get my bonus. So if you are a statistical person, if you are an analyst, based on your analysis, based on the statistical significance, you will be removing this. But based on the business significance, you cannot remove this because this has been achieved. Maybe he was performing this, but in the month of July, there was something, he came across a client and he sold for 30 million naira. So from business significance point of view, you cannot remove without permission. From statistical point of view, you can remove. But then the business will ask you, business will question you. So never remove any extreme value, any data without the permission of business. Because they understand the business. They know what happened over here. Because when you are investigating this extreme value, you are actually investigating what happened this day. A project is not done by sitting on a laptop inside a room. Remember, a project is done by meeting all the stakeholders, asking about the business, investigating all the cases. Only after investigation, you will treat the data. Only after investigation, you will remove some outliers. Only after investigation, you'll be able to manipulate the data or transform the data. And this you will face, or you may be facing in the real world. So this is a difference between the statistical significance and the business significance. Now, we were talking about this. So if you look at these 5 summaries in any data, this will give you a very clear picture that what is happening inside my data. Before going to any analysis, you must look at this summary. Must understand that there's a difference between minimum and maximum. There are possible outliers. There are possible extreme values. If the difference between Q3 and QR, that is IQR, if the difference is very high, it means your data is not stable at the mid-level. If your minimum range is bad, it means your data has a problem at the end, at the tail side. If the IQR is bad, it means the problem in the data is in somewhere in the center and not at the extreme. So, what is Q1? What is Q1? What is Q3? Q1 is nothing. This is the 25th percentile of your data. It means age. What does this tell you, Q1? It says that 25% of your data values, we have 442 data values for age, 442. It says that 25% of total 442 values has an age of 25 and below. Total data of the total data value, 25% has age of 18 and below. Q3 says that of the total data value, 75% of total data value has an age 30%, 30 and above. That is 75th percentile of Q3. 75% of the data, 75% of data of the total values has an age of 30 and above. Rest in the median, in the 50%. Q1 is 25% of the total data value has an age of 18 and below. Quartile 3, 75% of total data value has an age of 30 and above. But then, how does it help you? How are you going to apply in your business? This will actually show that what percentage of people are performing very well. And what plan of action do I need to create for the people below 18? So this actually gives you an idea that how many plans of actions you can create for your teams or for the project based on this summary. This is just a basic, it's just a first view of the data. We have not been looking at it in the graph, just on Excel. And you get a lot of idea from here and what is happening inside the data. So this is the gist of the summary and why this is there. And this is very, very important. Understanding this is critical.
Sir.
No? Yeah.
Can the third quartile,
yeah,
can the third quartile be lesser than the first quartile?
Yes, it can be. Because it depends on the distribution. But normally, ideally, if you see, when you are finding median, let's understand this. When you're finding median, the first step is to put it in the ascending or descending order. Okay, so I say 100, 85, 80, 75, and 70. First, you have to arrange your data in the descending order. So now when you arrange the data in descending order, what will happen? This is your median. This is a median. So it is very clear that the quartile 1 will always be lower than the quartile 3 because you have already put it in the descending order. So your quartile 1 is here, and this is your 75 and above. This is your median. Is this clear? So never forget to put in the descending order if you are only checking the median. That is the rule. Then we will talk about mean and median, which is higher or not. So just hold on. I hope this part is very clear. Please ask me a question on this part because this is very, very important to start any project or to start understanding data. This is the foundation. This is the pillar. And you must understand the concept. Yeah.
Yeah, please, can you recap on the high QR, how it applies to business analysis?
Okay, let me plot a graph. Let me plot a graph and you'll be able to see this. See, when you get an error, this is what will show you. Argument Y is missing, right? So now, let's say you get this error and you want to find the right part. It says one argument is missing over here, the way we have in Excel. So it is asking you for something, the mean, median, something is asking over some argument. So I know, but let me tell you, I will go to help and I will say QQ plot. It'll tell you how to use a QQ plot. What is the argument missing? You will get an idea. See, QQ plot, it has so many arguments. So if I say distribution is not norm, it means I was missing an argument over here. So if I say distribution is equal to norm, still it's giving me an error. It says still your Y is missing. So now, from where should I get Y? We have a lot of support over here. We come here, we also see an example. Now, how do we use QQ plot? And that's how you will learn R. See the example. This is R square. This is QQ plot. Then data is equal to this, subtype is equal to type. I mean, you have so many ways of plotting it. I want to see. Just hold on. Let me get you the right code so that you don't get confused. I want to show you the right code. The easiest one. Okay. Take a lot of time. So I wanted to plot this to show you. Can you see this? If you look at this graph, this plot, you see this, there are some extreme values over here. But this middle part, you will not see much deviation in the middle portion of this. Similarly, towards the end, you will not see much deviation except for one or something. But you can see the age moving down towards this one. You cannot see too much of clustering. You can see that most of the data points, they are not close to each other. In the middle, you will see that there's not much problem. The distribution looks same. But towards the end, there seems to be some challenge. And that is why when you say 2, 3, you are trying to see data with two angles. Always see the data from two angles. One from mean side, one from the median side. Because what do you see in data? I want to see the ends and I want to see the center. So when you look at the data from mean perspective, you will see the entire data. If you look at it from the median perspective, you are actually looking at from the middle value Q1 and Q3. So this data you can see that towards the center in the middle, the data is stable. You don't see much difference, but you can see the differences over here. I have taken two variables. One is work experience, one is age. I'm trying to compare this. You see the age in terms of the work experience, you can see the blue ones. There are some lot of data outlier extreme value. But if you see in the terms of age, we saw that the minimum was 18. This is what it is. Minimum one, 18. If you see the blue one, work experience, you see some extreme values over here for the work experience. But the age is ending over here, the red one. And that is what we see when we compare the mean, a median, or range with the IQR. You see the range as an entirety in data. You see the IQR towards the middle of the data, the dispersion on the middle side. Is this clear? Have I answered your question?
I think his mic is on, but the understanding is very clear.
Very clear?
Yes, please.
So you're certified here. So I'm certified by you. Is it?
Yeah.
Oh, thank you. So now that we have an understanding of looking at the data, looking at the summary, now let's understand, we will look at the same thing in a different way. We will create a box plot. And I'll explain to you what is a box plot. How this is a very powerful tool. This comes under 7 basic quality tools. But not everyone knows the power of this tool. How well this will visualize the data for you and what all important critical findings it can give you. So I'm making box plot of age and work experience together. Now let's understand this. All these things, as I said, guys, don't worry about R Python. It takes you 10 seconds to put in a code. But understanding this will take you lot of time. So I want to discuss the box plot, which is a very, very basic tool of any analysis. But this is a very powerful tool, which we will discuss after a break of 10 minutes. Just refresh yourself. Just 10 minutes and we'll be back. Okay, so we are back. So let's understand the box plot. These are common tools most of you must have used, but understanding these tools is very, very important. So let me add one more variable to the box plot, and we will see all the variables together. Remember, the box plot is always made with continuous data. Box plot is always made with continuous data. So we are taking the continuous data, age, work experience, salary, and distance. Now, whenever you see this, pink icon. This means that this data, this variable is in this data. Don't pick up the other ones. When you see the pink one, this is stored in your data frame. So always pick with a pink. So let's analyze, let's visualize the data from here. We can also make a colorful box plot. So let me make a colorful box plot for you. So in R, you have a lot of things, they're not mandatory. You can use them at your choice, and as you practice, you will get to know all the features, and all these features can come from here. You see, if I say box plot, if I say box plot, it will give you all the features, what all you can use. So all these things, you have to play with it. The way we play with our mobile, new mobiles, this is the way you have to play with it. You can use these, you can change, you can try different methods. So this is the box plot with horizontal shape. Let's first understand this is the same thing that we saw in the summary: minimum, median, Q1, Q3, Q2, median. This is what it is. We are just looking at with a graph, with a plot. Here, you might not see the mean. You will see the median. This value, the last one, is the minimum value. This is distance. We were talking on age. Yeah, hello?
Oh, yeah. Maybe can you use your cursor? That could be very easy to can see your
Okay,
slide.
maybe I can share the screen. So screen is Can you see the box plot? Can you see my R screen? Can you see the R screen? Can you see the box plots?
Yes, they are seen.
Okay. So let's say this is the age we saw with a summary. And we saw that because of the minimum, maximum, high range, you can see these two, three data points. You can see these 2-3 data points moving ahead, moving outside the entire box. This line is the minimum value. This is called the lower whisker. This is called the upper whisker. So this is the upper whisker, this is a lower whisker. This is your minimum value. This is your maximum value. This is your median. Remember, larger the box, larger the rectangular shape, more the variation, more the standard deviation. This is what it indicates. So if you see from here, distance has the maximum variance or standard deviation. This one also has a high variance. This has the minimum. This one, and forget this. This one has the minimum variance because the box size is small, the rectangular shape, this one. One more thing we must see when we are plotting these box plots together. What are we trying? We are trying to improve something. We are trying to improve our Y response by making changes in the X's, different variables. Our variables today, age, salary, work experience, distance. Based on these 4 variables, we are trying to make some changes in response. So this will change only when it is correlated. What do you mean? Now you understand correlated? You can run fast. You can run faster only when you are healthy. It means your health is correlated with your speed of running. So if you improve your health, your speed will increase. Similarly, we're trying to change some Y with the help of these variables. It means this should be correlated with your Y, this should be correlated, this should be correlated. Because if they are correlated, only then you can change. If there's no correlation, if the water pipe is not functioning, you will not get water. So if there's no correlation, you will not see a change in Y. So whether they are correlated or not, it is important to see. If you see these boxes, this one, this one, this one, they are overlapping. They are in the same line or almost parallel. It means these two variables have some correlation between each other. You see, this one is totally, see age. Age is totally different from others. They are not even in the same line. They are not overlapping. It means age is different from these variables. These two are not different from each other. These two are not much different from each other. It means, let's say in your business, let's say you are in a contact center or customer service. You have a team of 20 people. 5 people are performing at a similar level. 2 people are performing at a very different level. It means these 5 people, 1, 2, 3, 4, 5, they are not different from each other. Maybe they have good knowledge, maybe their experience is good, maybe their computer system knowledge is good, but the other 2 people, they are not matching with your team. They don't possess the same quality what these 5 people possess. So this also indicates that those 2 people need to work on something. So this is visible from here, that this distance and age, distance and salary, the data inside this, there's not much different. The average is not much different. But age and distance, they are highly different from each other. This is what we see in a box plot, how we see the IQR, how we see the median from the box plot, and we will use them. When we learn this, when we are doing assignment, when we are doing the learning, we will use the box plots, and we will learn with example as how we are going to use it in our data.
So just one question here. Does the overlapping of these boxes means that two variables are correlated?
Yes. No. What it means that these two variables are not different from each other. But okay, so these two may be correlated. These two may have multicollinearity, and now I'll talk about the multicollinear. Right now, what we are seeing, the data, the pattern of data, mean, average, whatever we're checking, this is significantly different. Age is different from distance. Age is different
plus
from
and distance correlated? Plus and distance variable?
yes, maybe the plus and this variable, they may be correlated. This one is correlated. How much correlation is with the Y, we don't know.
But
Whether
they can
this
be
is sorry.
But they can be correlated because the
Yeah.
graphs are
We are
over
not
that.
right now. When we are not looking at Y, we are just looking at all the X's.
Okay. Okay.
So I'm saying that X's, if you see, it says the work experience data is totally different from age. The data of distance and salary, they are similar data in terms of median, in terms of mean, in terms of quartile. Even if you look at the outliers, they are similar. This is what it reflects, and we will learn together, when we learn with R, when we work on the data. So this was about the summary, how we look at the summary, how we study the summary, how we interpret the summary, and how it affects your data, and how you can immediately identify whether there are extreme value outliers or not. So we have changed the types of data together. We have also attached the data. And here, this is what I showed you, how to change all the categorical together, which we created a factor. Now, let's see how to create a table. I want to see the table of transport. And remember one thing I told you yesterday. There are different libraries which you will learn as you use the functions. So for different functions, you'll have different libraries. So let's see the table. It says that if you see transport, it has 0 and 1. It only has 0 and 1. Yeah. So your R is saying, when you're looking at data, it says there are 383 zeros and 1 and 59 is 1. I mean, zeros are 383, ones are just 59. Why do we need to see this? This is important to see whether your 0 is 1. Is it balanced? If it is balanced, it means there's no difference between the defect and non-defect. Your defects are 383, your accurate is 59. Or you can take it the other way, the way we have defined the data. This is how it shows that how many are defects, how many are no defects. So you can look at the data this way. You can open the table, you can make a table, and you can look at the data. I will also, this R sheet file, it is already there on the platform. If you see, Here, under the data which we had seen, you can see R practice on R. Whenever you see practice on R, this is your R file. You can download this file and you can practice the codes the way we are doing. But however, I suggest don't copy and paste on R from here. Type yourself. When you type, you will get a better practice. So this is the same file I have uploaded over here. You can download on your laptop and you can start practicing on this. So from next
Under
session,
file located, sorry. Under
Sorry?
which header the file is located?
here it is. Basic statistics. Basic statistics.
Okay.
So before we close for today, let me just explain one more thing, which is again the foundation, or you can say the base of any statistics. This is the base of any statistics. Sorry for the line. I'm drawing a normal graph, a bell curve. What is it? In our life also, personal life also, we want a very normal life. We want good money, good personal life, good job, good food, good health. This is our desire. This is our wish. So even your companies, they want a very normal curve. Performance should be normal. In order to do this, you have to have a normal distribution. Your distribution should be very normal, even in your personal life. This is what we expect from life. But in reality, it doesn't happen. So universally, or as a thumb rule, when we take the normal distribution, the mean is always at 0. Why the mean is assumed to be at 0? Let's say I have 5 teams. Team 1 is at 85%. Team 2 is at 75%. Team 3 is at 90, 40, 50. When you have 5 teams, what is the best expectation? What is you as a manager? What is the best expectation from your team, or all 5 teams? Tell me. What is the best expectation? The highest expectation you have from your team?
All
This is
the
how it
teams will be well.
Sorry?
All the teams should perform equally well.
Excellent. So actually you want that all your 5 teams should perform at the same level. It means the mean difference among the 5 teams should be 0. There should be no difference in mean amongst all 5 teams. That is the dream. That is my assumption. But in reality, it doesn't happen. That is why in a normal distribution, your mean is equal to 0. Your standard deviation is assumed to be 1. Your standard deviation is assumed to be 1 in anywhere in life. So, when we talk about the standardized mean or a normal distribution, our mean is supposed to be 0 and a standard deviation is supposed to be 1. That is the assumption. That's my expectation. When we talk about the data distribution, we talked about two things. One is the distribution, that is central tendency, and the second is the dispersion of data, which is the standard deviation IQ or we have learned so far. In terms of the central tendency, we have learned the mean and median right now. That is the distribution of data. And one is the deviation of data, the dispersion of data. So by default, universally, if you have a normal distribution, it is set that 98% of your data values are distributed of the data values are distributed between -1 and +1 standard deviation. -1 standard deviation is here, 1 is here. It means %68 of my data distribution as a normal distribution, my data values are here. Between 1 and -1 standard deviation. Standard deviation is always from 1 to 3 or -1 to 3. It means if you divide this, you can say, 33.5% here, 33.5% here. Or yeah, if you talk about this part, if you talk about -2 to +2, this part, 95% of your data is distributed between -2 and 2 standard deviation. That is 95%. When you come to distribution of standard deviation 3 and 3 -3, if we talk about this part and this part, 99.7% of your total data values are distributed between 3 and -3 standard deviation. This is an empirical universal formula. You don't need to learn all these things. This is more from the understanding perspective. So you don't need to learn any formula or what this is. I'm just giving you the basics that this is the universal truth. 68% between -1 and 1, 95% between -2 and 2 standard deviation, 99.99 this between -3 and 3. Then what happens to the remaining? That is defect. This part, whatever you see, this is defect. That may be point some percentage. Here, this part is defect. This is a normal distribution. We will get into the more detail when we move to stage 2. Another very, very basic question which is always asked.
Sir.
Remember, yeah, sorry.
Yeah, I want to find out, based on this beautiful explanation you've given, so can I say that the closer the standard deviation or the lesser the number, the better to the mean.
Of course. Yes. Your standard deviation should always be low. Why should you make mistakes? It should be closer to the mean. Yes.
Thank you very much, sir.
Now, one thing that I want to show you. There's a very basic question, very basic thing. This is your X line. Remember one thing. Whenever you have a graph or a curve, you always have it like this. This line and this line will never meet. They are always parallel. In any graph, these two lines will never meet because we are working on probability. And probability is never 0 or 1. It's infinite. So these two lines, whenever you see a graph, whenever just observe, these two lines are parallel to X line. These two never meet. So we will upload the video. Please pay attention because practically when you are new to a subject, it is not easy to grasp everything in one session. It's not easy to catch up with everything in one session. And that is the reason we have recordings. As I said, we have support system throughout the week, but you have to practice. You have to study. We cannot make you a champion in 8 weeks, or we cannot make you understand everything in 3 to 4 hours. Practically, you also understand, I also understand, it's not possible. The idea is to give you the concept which you may not have heard of. And I strongly believe in the concept and the basic as a foundation. I can run the code that I can do the Power BI for you, but you will not be able to learn, you will not be able to meet the objective of this entire program. So must understand the basics, must listen to the videos, see the videos. You have this video, plus you have more videos of batch 1. The modules will be similar, but sometimes I teach you something which maybe I may not have covered in the other batch. So you have a lot of modules, a lot of videos to watch and practice. Any question before we call it today? Any question?
Thank you for the class. Thank you for the class, not from you.
Any question on chat? Okay, everyone, thank you so much for your time and enjoy the rest of your Sunday. We'll meet again next week, but please do watch the videos, do ask us for support. We have an email address, academics@abscanalytics.com, which is mentioned on your readiness letter, onboarding letter. Any question, any query, you can write to that mail. If you want to connect with us for on-call queries or guidance, you are welcome to schedule a time with us and let us know, and we will connect with you to resolve your queries.
Ghanaians, I don't think we create a group.
Okay.
My brother.
Yeah, thank you so much for your time. Take care. Good night.
I'm asking of.
Sorry? People who joined us for a demo session, people who wanted to see how we train. If you are interested, please do register yourselves because we cannot afford to give additional free sessions. Whatever free sessions or the demo sessions we have already provided to you, So in case you are still planning to register, enroll yourself, please do that as fast as possible. Okay, thank you. Good night.